objective for today, I can solve systems of linear inequalities by graphing. Let's read together. 1, 2, 3. I can solve a system of linear inequalities by graphing. So, today instead of just being linear inequalities, we're actually focusing on systems of linear inequalities. Okay? So, that's why last night I left you guys plenty of practice for the graphing part. Today we're going to continue. And now instead of just being 1, we're going to do 2 per graph. So with that said, copy this down. It says system of linear inequalities in your Fourier model. It says a set of 2 or more linear inequalities that have the same variables. Examples, y less than or equal to 3x plus 1 and negative 4x plus 2y greater than 6. That's 1. The other one is negative y less than x minus 5 and y greater than or equal to 2x plus 1. And non-examples, y equals 1/2 x minus 2, 4x plus 2y equals 12, and y greater than negative 2 plus 1/2 x. Copy that, please. Okay, here we go. So, as you're finished copying the non-examples, here goes the definition. The definition says a set of 2 or more linear inequalities that have the same variable. Set of 2 or more linear inequalities. Let's see. Do I have a set here? Yes. 2 or more? Yes. Linear inequalities? Let's see. Do they have inequality symbols? Yes. 2 variables? Yes. So this is a system. Here's another system. So why is this not an example? Why is this not an example? So, tell your neighbor why these 2 are non-examples. Go. So that's true. The most important thing to remember about system linear inequalities is that they have to be 2 or more linear inequalities, and they have to have the same variable. Copy that, please, so we can copy our steps. Alright, copy these steps down, please. 4 basic steps: solve for y, graph the inequalities, check point and shape the solution set, state the domain and range of the solution set. And notice that it looks very familiar to what we wrote yesterday, right? Except for step 2, instead of inequality, it says what? Inequalities, because now we're looking at systems. Okay, copy that, please. So if you notice, it's the basic steps that we did yesterday. Today we're going to do the same thing with the graphing piece, but before we get to graphing, what did we do first yesterday? We did the checking, is that correct? To check if the point was part of the solution set without graphing, remember that? Today we're going to do the same thing. We're going to start first with checking if a point is part of the solution set of the system. So, on your paper, turn it over, please. Example 1, copy this, please. In the back of your Cornell notes, it says, tell whether the order pair is a solution of the given system. And they give us negative 1, negative 3, and the system is y less than or equal to negative 3x plus 1, y less than 2x plus 2. Copy that, please. So, remember yesterday when we checked the point for one inequality? Well, how many inequalities do we have now? 2. That means we need to check both. So therefore, draw a line down right here. Let's write one inequality on the left, y less than or equal to negative 3x plus 1. And the other one is y less than 2x plus 2. Label your point. This is x. This is y. So let's substitute into here. This is negative 1. And the y is negative 3. Bring everything else down. So what is negative 3 times negative 1? Positive 3. What is 3 plus 1? 4. Is negative 3 less than or equal to 4? Yes. So this one worked. Now let's check this one. So this is negative 1. This is negative 3. Bring down the rest. Negative 3 less than negative 2 plus 2. What is negative 2 plus 2? 0. Is negative 3 less than 0? No. Yes. Yes. So if it's true for both, listen to what I just said. If it's true for both, therefore, the point is part of the solution set 10Q. But when is it part of the solution set? When both of them are the are true, right? When it works for both. So you remember what I just said?
When both sides are yes, then true, then part of it both.
Okay? So, with that said, any questions with checking without graphing?
Yeah. I mean, no.
No. Okay? Then do this next one by yourself, please. Copy this one, example 1B. Copy this one, example 1B. You don't need to write the verbatim anymore. Just copy the point, -1, 5. And the system is y less than -2x minus 1 and y greater than or equal to x plus 3. The verbatim is the words.
Verbatim.
See what you get for that one, please? All right. Who checked the first one already?
I did it.
What'd you guys get, everyone?
No.
No. Did everybody check the second one already?
Yes.
What is that?
Yes.
Yes.
Oh, no,
So this one is no, this one is yes. So this one worked for one, not the other. Therefore, the point is not part of the solution
What do you say it's not?
set.
No.
There's only one point.
Oh, I see.
The point is not. Huh? I what?
I heard that from you.
I wrote what? The point is not part of the solution set. 10Q. All right. Any questions with the checking? Let's go to the graphing piece. Copy this next one on the big graph on the top left. All right, here we go. So example 2A says, graph the system of linear inequalities, okay? Give two order pairs that are solutions and give two that are not solutions. So here we're going to give how many order pairs? 4 of them. 2 that are, 2 that are not, okay? So the system given, -3x plus 2y greater than or equal to 2, y less than 4x plus 3. Copy that, and then we'll go over it together. All right, here we go, everyone. Step 1 for solving systems. What do we do in order for the graphing to take place? They need to be solved for y. Is that correct?
Yeah.
Look at the first inequality. Is it solved for y already? No, so let's write it underneath. I'm going to write it right here, -3x plus 2y greater than or equal to 2. Let's solve for y. And you get rid of the x, therefore I do what? Add 2x, add 2x. Oh, 3x, my bad. I did it on purpose to see if you were paying attention. So this is 2y greater than or equal to 3x plus 2. Yeah, the 3x, okay. And am I done? No. I need to divide by 2, divide by 2. Y greater than or equal to 3 over 2x plus 1. Why did I leave it as a fraction, this one, the coefficient of x? We need the slope to do what? To graph, exactly. So we're done with this one. How about the second inequality? Is it already solved for y? Yes. So therefore, I'm going to graph this one with blue, the second one, and the first one that we changed to y form, I'm going to graph that with red. If you don't have those colors, get 2 different colors of a kind. Or if you have a pencil and a pen, use a pencil and a pen. I'm going to start with the red one. Let's graph this one. Where do we start? At +1. So plot your point at +1. There it is. What is my slope? 3 steps up and 2 to the right. Let's do that. 1, 2, 3, 1, 2. Plot your point. Let's do it again. 1, 2, 3, 1, 2. Plot your point. Let's do it again. 1, 2, 3, 1, 2. Plot your point. Do it again. So, before we graph our line, let me zoom in so you guys can see the inequality symbol. What? 1, 2, 3, 4. 1, 2, 3. All right. Look at the inequality symbol, everyone. Look up, please. Look up. Look up. Who notices that this inequality symbol has an equal sign right here? That's what I mean. That's what I mean when I ask, does it have an equal sign? This little bar underneath, if I was to cover this little piece right here, it becomes an equal sign. Does everybody see that? If it does have an equal sign, that means that our line's going to be a solid line. So when we graph our line, get your ruler, make sure it goes through all those points all the way across your coordinate plane, and that it's a solid line. Okay? So, at this point, now we need to find out which way to shade for the solution set just of that line. So let me see. I'm going to use red. Look up, please. And what information do we need from our inequality? We need the y greater than or equal to, what else? And the plus 1. Okay. So here's plus 1. And let's read the inequality. The inequality says y is greater than or equal to 1. What numbers are greater than or equal to 1? On the y-axis, what numbers are greater than 1? 2, 3, 4, 5, 6, all these, including the decimals and fractions, right? That means we shade everything above this line. All right, we're done with that one. Now let's go with the second one, the one in blue. Where do we start? 3. Positive 3, right here. And what is our slope? 4 up, 1 to the right. So we go 1, 2, 3, 4, 1 to the right. Plot your point. Let's do it again. 1, 2, 3, 4, 1 to the right. Plot your point. Do it again if it fits. So now, let me zoom in to the inequality symbol of that inequality. Does it have an equal sign? Look up, please. Does this one have an equal sign? No. If it doesn't, then that line has to be what? Dashed or dotted, right? So let's graph that. I'm going to do that in blue. Make sure it goes through those 2 points, and it's a dashed line. There it is. Are we there so far? All right. Now we need to shade the solution set for that line. So what information do I need from this inequality? The y. What else? What else do I need? The inequality symbol. What else? And the plus 3. So let's see. Here's plus 3. Let's read it. Y is less than 3. What numbers are less than 3? 2, 1, 0, -1, all these, including their fractions and decimals. So that means we're going to shade everything under or to the right of that dashed line. Does everybody see that? Okay, do that, please. All right. All right, so check this out. Everybody look up, please. Pens down. Look up. Look up, look up, look up, look up. Now, who notices where both colors intersect?
Oh, me.
Okay, well, guess what? When we're solving systems of inequalities by graphing, where both colors intersect, let me show you with black. Look up, please. This is the section where they both intersect. This is what we call the solution set, where both intersect. Label that, please. All of that. Now, it says here to choose 2 ordered pairs that are part of the solution. So look at it. I'm going to pick 1. The first one I say 2, 5. No, I'm going to pick 2, 6. 2, 6 is right here. Is that part of the solution set? Yes, so the first one is 2, 6, okay? What would be another one, Danielle? Another point on the solution set? 310. Does everybody agree with that? Yes, 310. So any point within there is part of the solution set. Now, if we wanted to test it, we know how to test. So what does that mean? That if I pick this one and I substitute into both inequalities, it has to be yes and yes. Is that correct? All right, so therefore, let's pick 2 points that are not part of the solution set. Now, an easy one that you can see is here. Why? Because that's only going to be yes for the red one, but not for the blue one. Does that make sense? If I pick one on this side, it's going to be yes for the blue one, but not for the red one. Do you see a third region where none of them will work? Where is it at? Down here where nothing is shaded. So that one will not work for either one or the other. It won't. It would be no and no. This wouldn't be a solution. This wouldn't be a solution. This wouldn't be a solution. What is the only, or what are the only points that are part of the solution set? Everything in that overlapping region. Everybody got it? Fairly simple? Piece of cake? All right, so do this next one by yourself, please. Y less than or equal to 3x minus 4, y greater than negative x plus 7. They're already solved for y, so just practice your shading. And in the meantime, yeah, in the back, it's fine. Your home plate for tonight, well, I guess you can do that by yourself at home. Here we go. Pages 316 through 317. If I don't see you in tutoring, I'll see you guys tomorrow. So have a good one. Enjoy your home play. Bye.